Here's practice problem number 12 on page 210. And we have a 0.5 kilogram ball traveling at 6 meters per second. It collides head-on with a 1 kilogram ball moving in the opposite direction at a speed of 12 meters per second. The 0.5 kilogram ball bounces backward at 14 meters per second after the collision. Find the speed of the second ball after the collision. Okay, so let's do given, find, and solve here. And with collision problems, especially one like this, it's really important that you draw a picture of it and you really get the directions of the initial and final velocities right. So a 0.5 kilogram ball is traveling at 6 meters per second. So I'm just going to make, and I'm going to call that M1. So here's M1, and I'll say M1 equals 0.50 kilograms. And we'll say that it's going this way. So I'll show a little. And so V1 initial equals 6 meters per second. So I'm deciding that to the right is positive, which is what we usually do. Now it's going to collide head-on with ball number 2, and it's bigger. It's got a mass of 1.00 kilogram. And it's moving at 12 meters per second in the opposite direction. So it's moving this way to the left. So I'm going to say V2 initial is equal to negative 12.0 meters per second. Now what if you switch these? As long as it's very clear that you've made ball 1 over here going to the left and ball 2 going to the right, it's okay. You'll get the right answer, and everything will work out. Now this is before the collision, and then they hit and then they fly apart. So this is after the collision. So here's ball 1 after the collision, and it says it's moving the opposite direction, bounces backward or opposite at 14 meters per second. So this is V1 final is equal to negative 14 meters per second. Now here's ball 2. We don't know what its final velocity is. That's what we're trying to find. And by the way, we don't know what direction it is. Is it to the left or is it to the right? Don't know. But we can find out. So let's solve it. Well, in all collision problems in this class, we're going to start off with the initial momentum of my system will be equal to the final momentum of the system. Why? Because when they hit, they apply equal and opposite forces for the same amount of time. Therefore, they have equal and opposite impulses, equal and opposite changes in momentum. If I add the momentum, the change in momentum of object 1 to the change in momentum of object 2, it will equal 0 because the impulses equal 0 when you add them together. Make sure you understand that chain of logic. That will be on the test. I'm going to ask you to explain why is momentum conserved during a collision. So I look at the problem initially. I have two objects that are moving, and up here, and so I'll say M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. And I'll put little vector hats on the velocities. Now you have a choice. You can plug the numbers in now and then solve for your unknown. I like to solve for my unknown and then plug in all the numbers. But that's your choice, and I mean, you can do it however you want because it's all good. So V2 final is going to be equal to this, M1 V1 initial plus M2 V2 initial. And then I'm going to solve for this, I have to subtract this, so this is going to be minus M1 V1 final And then I'm going to divide by M2. Okay. Now I'm going to plug in my values. And I have to be really careful with negative and positive values here. V2 final is equal to M1 is 0.5 kilograms. V1 initial is positive 6 meters per second. Plus M2 is 1 kilogram. And this is V2 is negative 12 meters per second. And then minus M1, which is 0.5 kilograms, times M1 final. And V1 final. V1 final is given to be negative 14. So we have minus a negative here. We're going to divide that by M2. And M2 is 1 kilogram. So it's kind of nice that it was 1 kilogram. It makes a lot of our math easier. And let me check my work here. So I'm solving for this, so these stay the same. Subtract this, divide by M2. That's V2 final, yep. Okay, and then this was positive. V2 initial was negative. V1 final was negative, but we're subtracting it. So actually, if we're subtracting it, I can just go boom, boom like that. I don't think I need to use my calculator here. What is 0.5 times 6? That's 3. What is 1 times negative 12? Minus 12. What is half of that? That's 7. And then I'm going to divide by 1. If you want to plug all that into your calculator, go for it. What is 3 minus 12? Negative 9. What is negative 9 plus 7? Negative 2. Now notice that the kilogram cancels the kilogram in every term on the top. The units left in every term is meters per second, which is what it should be. Now you have to have that negative there, because what does that negative mean? It continues going to the left. Or if you said to the left, or if you switched them, and I see that it's switched and you're saying to the right or positive, that'll be good. Okay, so there's your whole problem. And there'll be a problem similar to that on the test. Any questions? That is all.